As we know that force is simply defined as a push or a pull. When we push an object or when we pull an object towards ourselves, we are applying force for it. But this is actually the simplest, the basic definition. The actual definition regarding force is it is an agent that changes or tends to change the state of a body. That is, force is an agent that changes or tends to change the state of a body. When we say that a body has some energy, then that energy can be used in changing the direction of the body or providing it a strength so that it can move. Now, the force that gives energy to an object can stop the moving object, and if the body is at rest, it can start to move the object, or the force that we have applied on an object can change the direction of the body as well. Now, as we know that force is actually a vector quantity, it's a drive quantity as well. Force is a drive quantity and it is a vector quantity as well. Why it's a vector quantity? Because it needs a direction for the complete representation or specification. The SI unit for force is Newton and it is represented by capital N. Now if you're going to define 1 Newton force, how will you define 1 Newton force? 1 Newton force is actually that force when applied to a mass of 1 kilogram body, it will produce an acceleration of 1 meter per second square. So how will we define 1 Newton force? 1 Newton force is that force when applied to a mass of 1 kilogram will produce an acceleration of 1 meter per second square in it. Now the types of forces. Contact forces, when two bodies are in contact, we say that the two forces acting on it are contact forces. For example, if you have placed a book on a table, then the forces which are acting together are the contact forces. Like the weight of the book is acting in the downward direction on the table, whereas according to Newton's third law of motion, to every action there is an equal and opposite reaction. As a fact, the reaction of this force, that is the weight of the book, which is provided by table, will be in the upward direction of equal magnitude. So the weight of the book, that is acting in the downward direction, whereas the reaction of that provided by the surface of the table is in the upward direction. So this is about contact forces, and we say that W is equals to R, where W represents the weight of the book and R is the normal reaction provided by the surface. Now for non-contact forces, for example, if we are talking about a magnet and a magnetic material, so although these two bodies are not in contact, but a magnet has the property to attract that magnetic material towards itself. Like for example, a bar magnet can attract the iron and the other magnetic material towards itself. So this is an example of non-contact forces. In the same way, like when we talk about the force of gravity, we know that the gravity attracts a body towards itself. So if you have an object at a certain height and if you drop it, so although the two bodies are not in contact, that is the earth is not in contact with that body, but earth has a gravitational force, that is the gravitational field strength, due to which it attracts the body towards itself. In the same manner, when we talk about the two opposite or the two same charges, although when the two charges are kept apart from each other, but even the two charges either show a repulsive force or an attractive force. repulsive in the case when the two charges are of same nature, whereas an attractive force when the two charges are unlike, that is of different nature. Another example for the contact forces is friction as well. Friction is also an example of contact forces. So if you slide a body on the surface of another body, an opposing force is set up that resist the motion of a body, and this force of friction always acts in the opposite direction of motion of the body, and it depends on two factors. Number one, the weight of the sliding body, and secondly, the nature of the two surfaces in contact. So if the two surfaces are rough, then the force of friction will be maximum, and if the two bodies are smooth and like two metal surfaces in contact, they have the least force of friction. Whereas, for example, the road and the concrete road and the tar, it has the maximum force of friction. That's why it provides a grip to the car so that it can smoothly run on the road without slipping. Now for the non-contact forces, that is the force that act without touching each other. For example, as I told you, gravity, force of gravity, that is the gravitational field strength, the force of attraction due to the pull of the gravity. Another example, as I gave you, magnetism, that attracts or repel the objects. So when we talk about two magnets of same polarity, then they will repel each other. They will repel each other, whereas two forces of opposite nature, they will always, two poles of opposite nature will always attract each other. Okay, when we talk about gravity, we know that the gravity always tries to pull an object towards itself. And when we define for weight, we say that weight is the force with which the gravity pulls a body towards itself. So the pull of gravity varies from planet to planet. Like the gravitational field strength on the Earth surface is 9.8 Newton per kilogram. Whereas when we talk about the pull of gravity on the surface of Moon, it's 1.6 Newton per kilogram. In the same manner, when we talk about the acceleration due to gravity, and we also symbolize it by small g. So when we talk about acceleration due to gravity, that there we mainly talks about the free falling bodies. Like if you drop a body from a certain height, it starts falling down. Why? Because of the pull of gravity. So during its downward motion, if we ignore the air resistance, then the body will fall down with a uniform acceleration of 9.8 meter per second square. But if the air resistance exists there, then this acceleration will gradually reduce. If a body is falling from a very high altitude, then because of the air resistance, the change in the resultant force will gradually decrease, and finally, when the body moves with a uniform velocity that we call terminal velocity, there the resultant force will be zero and the acceleration of the body will also becomes zero. When a body falls under the action of gravity, then this acceleration is independent of the mass of the body. If you throw two different bodies of different masses, if we drop two bodies from the same height or having two different masses, so if we evacuate the air and create a complete vacuum condition, then we will see that both the bodies of different masses will reach to the ground in same time. It means that the pull of gravity is independent of the mass of body, because the gravity pulls a body towards itself irrespective of the mass of the body. So if you will drop two different bodies of having different masses from the same height in the absence of air in a vacuum condition, then we will see that both the bodies will reach to the ground in same time. So when we are going to differentiate between mass and weight, the first point should always be of their definition. What is mass? Mass is the quantity of matter present in a body. Whereas when we talk about weight, weight is the force with which the gravity pulls a body towards itself. Now, the SI unit for mass is kilogram, whereas the SI unit of weight is Newton. In the same manner, the mass of a body always remains constant. This is the third difference. The mass of a body always remains constant wherever you take it. On the surface of the moon, on Jupiter, on the surface of the earth. So mass of a body always remains constant, whereas weight of a body varies place to place with respect to the altitude. Because weight is the product of mass and gravitational field strength, that is W is equals to mg. And we know that weight is the product of mass and gravitational field strength. So as g varies with respect to the different planets, due to that the weight of the body will be different at different planets. But mass of a body always remains constant, that is unchanged. Then, because mass does not need any direction for its complete specification, that's why mass is a scalar quantity. Whereas when we talk about weight, we know that the direction of weight is always towards the gravity, that is in the downward direction. So weight of a body is a vector quantity.